I'm at the Walker Turner drill press, and you know what I like to do with a Sharpie here? I mark the sizes. For instance, this is a 3/32 hole. I don't know if you can see it, but I marked that 3/32, and this 1/8 inch. I'm not doing that for your benefit. TUBALCAIN is doing it for his benefit, because you can spoil the work real quickly, you know, with the wrong size bit. So this is an 1/8 inch bit in the press here, and I'm going to drill that hole all the way through both walls, and you'll see why later on. That's optional, but that's what I'm going to do. Then I will drill the 3/32 also all the way through. I'll move this in the vise so I don't drill my vise. I don't like it when somebody drills through their work and into a vise. One of my pet peeves. I'm not going to show the drilling because that's pretty typical stuff, but two different sizes all the way through. There we have it, 1/8 inch hole and a 3/32, and again I drilled them through both walls. Later on I will run the reamer through here just by hand to clean it up, because there will be burrs on the inside. The hole, the 3/32 hole on the top will be used with the center, with a transfer punch all the way through to help me transfer the holes later on so that those ports line up. And you'll see what I mean then. But the purpose of this other hole running all the way through, let me explain it right now. I cannot emphasize enough how important it is that this rod be perfectly perpendicular with the work in both directions. Of course, a square, there's not enough area here to check with the square, but it has to be perfect, and it will be most evident later on when you assemble it and you find out that it wider at the top than at the bottom, or vice versa. And when you try to run the engine, you'll have a tremendous air leak there, or steam leak. That's why it's so important that that be perpendicular. And what is my solution to that? That is that if it is off perpendicular later on, pardon me, you can take a steel or brass rod, whatever your favorite is, and literally Loctite that into place as such. Then mount this in the collet or the 3-jaw chuck on the lathe, and very carefully face this with a very light cut so you get a good finish. And that will bring that surface into perpendicularity with the rod. I may or may not need to do that, and then later on both of these holes will be plugged and Loctited as mentioned previously. Let me turn my attention to the upright here. I've already put a center line on there, and I did that using the surface plate again to work up against that nice angle plate, and using the height gauge there. Do it by whatever method is your favorite, but that's highly accurate. Then I established where the pivot hole will be, the 1/8 inch hole where this will pivot. And I didn't have a dimension, so I just I laid the work on there where I wanted it, and I used a transfer punch and transferring it as such. Now I will center punch it and take it to the drill press and drill it 1/8 inch. Get yourself a little center punch, something like this. You'll like them, automatic center punch. Now it's ready to drill 1/8 inch, but I'll do that on the Cameron first. I always establish the hole on the Cameron. Old TUBALCAIN has quite a large selection of springs here in the basement shop, and I found one among in the selection. Got a frog in my throat. That is about 1/8 inch on the inside, so it'll go over the 1/8 inch rod. And you don't want too strong of a spring. You know, this is rather light wire, and I'll establish the length of it later. But what I'm going to do now is determine the outside of this. I'll just stick it into the drill gauge and determine what drill size, and then I like to drill a hole on the back side here, like right here. In other words, it's counterbored for the spring. And by doing that, you will not end up with a spring that's too long out here, because you don't want this nut, you know, to be way out here. And that helps reduce that length. Again, that's optional, but that's what I'm going to do now, is counterbore the upright. There's the counterbore, and I went about halfway through with the 13/64, and that just fits the spring nicely. Now make sure that you drill this hole on the correct side of your base, and I had to think twice about what is the front and what is the back, but this is the side that I'm going to establish as the cylinder side. So the counterbore was on the back side. And do set your depth gauge on the drill press so you don't accidentally, when the phone rings or something like that, drill the large hole all the way through and spoil the work. Next, I'm going to make the little rod here, and that's 1/8 inch brass. You can use any material. I wouldn't use aluminum. Steel or brass is okay. I'm using brass because I got it and it's soft and it's easy to cut the thread. Now remember that an 1/8 inch diameter is equal to a number 5, and I'm going to thread this 540. That's a 540 thread. Now if you do not have a 540 thread, do not use a 440. It is not the same. Now when you go to the hardware store and ask for a 540, they're going to argue with you, and it'll be a 40-year-old woman, not very good looking either, by the way, and she will say there is no such size. So in order to get that size, you need to order it from an industrial supplier if you don't already have it, or borrow it from somebody, or change the size altogether. But I like to work with common sizes, or common size rod, 1/8 inch, but the thread is no longer common for some reason. They don't like to stock those extra sizes locally in the box stores. However, you can get them. They eliminated some other sizes too. You very seldom see a number 14, like or a number 1224. You can find the 1024, but some of those sizes have just disappeared over time in the convenience of retailing. Here's the brass rod, and I've marked it with a Sharpie, so it's about 3/4 of an inch of thread in all, and I have the 540 die mounted in my tailstock die holder, which in turn is in Jacob's chuck. Now I'm going to do this under power, but you can certainly do it by hand. I do not like to do it in a bench vise with a regular die stock because there's a marked tendency toward getting a crooked thread. Now the speed that I'm going to use here is really way too fast, but I'm just going to be careful, but you might want to put it in back gears for this. Now I'll back it out of there, and hopefully I'll have a nice straight thread that isn't all torn up. There it is. That's a nice thread. Now I will cut this off to length. Whatever length this one is, I'll measure it. And then I'm just going to set it aside. I'm not ready to install it yet because I will need to do some other operations first. But at least that part is made. And then I like to set everything that I've got made in a container so I don't lose it or have it roll off the bench or whatever. I think I'll mention this, how I handle some of this small material. I'm holding it in soft jaws, and I've got it marked where I'm going to cut it with the Sharpie. And I like to take a 3-corner file and give it a few strokes to establish where the cut mark is going to be. Now don't use a big coarse hacksaw blade. I don't know where I got this, but it almost looks like a child's toy. But it's a super fine blade, and it works swell for cutting something like that. And with brass, the newer the blade, the better. If you never use your blade on a different material other than brass, or you have dedicated tools for that, you'll really notice a difference of the way the cutting tools cut the brass. Here's another little hacksaw. I don't know where that came from either, because I got so many auction items, but that's also got quite a fine blade. Otherwise, this will move on you, or the big hacksaw will catch on you, especially when we get into that brass tubing. But this is pretty nice. Then on my little 2-inch wide abrasive belter, I love to just square off the work and knock the burr off. But remember, with brass, the heat is conducted so quickly you will burn your fingers in a matter of 2 seconds. And she's ready to go. You know what I just did? I took this over to the 6-inch wide abrasive belt and cleaned that up. And it's as smooth as a baby's hind end right now. So that's just the finish that I want. And I've got the brass rod in there, just temporary. And inserting it here, like that, oscillating and holding it up to the fluorescent light above me, looking to see if there are any spaces in there. And it looked real good, so I may not need to do this check here or facing on the lathe, but the proof is in the pudding, so when I actually run it, I will know how good the fit is there. And if it is bad, you know, I can always face that off later on very easily. Now if you get to this point and this thing is just as crooked as a dog's hind leg, you know, and it's touching at the bottom and it's a 1/16 inch away up here, you know, you got to do some damage repair or rebuild some parts. And that's why it's so important to do all these other little steps that I showed you along the way to get the locations correct and the holes straight and perpendicular and get alignment that is just what you need, and it is not troublesome. Sometimes hard to do some of those as a beginner until you get the knack of working with metal. Next, I'm going to drill the hole and put the bearing in for the main shaft here. And I took the dimensions right off of this, and that hole is 1 5/8 down from the pivot point. 1 5/8, and I got a center line there. I already center punch that, and off camera I will drill that. Now the bearing that I'm going to use, well, first of all, I'm going to change the shaft size and use 3/16 brass for a shaft rather than 1/8 inch, for no good reason other than it give me a little more surface when I use a larger flywheel. I think it might be a little better. So this is 3/16 brass. Actually it's brazing rod, but you can get this in the handy rack, or you can use steel. It really doesn't matter. 3/16. Now my bearing for that is this brass tubing, thin walled, and it's by the way, this is the company K&S Engineering. You see those handy racks in hobby stores, and they got a nice selection of this stuff. But this is 7/32 on the outside and 3/16 on the inside, and still got a price tag there, 89 cents. This must be a pretty old piece. This is probably $4 now, and it weighs 1/10 of an ounce. So anyway, I will need to drill this hole this size, which is 7/32, and always double check everything. You just can't check your sizes often enough. And especially if you're not doing this work all in one setting. And yes, it is 7/32, and this will be held into this with a Loctite. Now if you don't have tubing, or you don't want to use tubing, solid rod is fine. I don't have a piece to show you right now, but solid brass rod would be nice, and you can drill it whatever size you want. And then if you don't want the Loctite method, you can also either press fit it in there, or use a little set screw from the side to hold it in place. So there are alternate ways of doing almost everything that I'm showing you, and nothing is cast in bronze. I cut the tubing off And this little saw works pretty well, but also a jeweler saw, but the blades are so delicate on the jeweler saw, they work well. And in some cases I like to use my Dremel type tool, but if the work is too long, you know, it's going to interfere with the body. But these come in different sizes, and they're also great for hardened stock. So I do like the little Dremel. Now I'll square up the ends again here and burn my fingers here presently on the abrasive sander. I will not fasten it in here because I may have to trim this, or I may even need a longer piece later on, but that's tentatively the bearing. I'm on the clausing lathe now, and I'm going to make this crank disc here, and I have in the chuck 1-inch aluminum that I just got from the scrapyard. You saw that big piece with a mushroomed head, and I've already faced the end, and now I'm going to center drill, and then pilot drill, and a 3/16 reamer in that order. Then I will turn it, because this material is really chewed up, somebody had hammered on it, and then I'll cut it off. So just those steps. And I'm using my new Skycam, so we'll see how that works. There's the center drill. Possibly I don't need to show you all these steps, but there's always a few beginners out there that maybe haven't done these operations. I'm going to drill just a ½ inch deep or less. That's all I need. Change the tool. 3/16 reamer in. That's it for the hole. While I'm at it, I usually take a countersink and just break the corner of that hole. I'm going to turn it down just enough to clean it. In other words, I'm just taking a skim cut. I'll chamfer the corner. Change the tooling. Put in my cutoff tool. About 3/16 is what I wanted as far as the width. I'm going to lock the carriage. I like to do that when I'm cutting off. Alright, here we go with the Loctite. Remember, when you use Loctite, it shouldn't be a press fit. There needs to be a little room for the Loctite to get in there. And I don't own shares of Loctite, although I wish I'd have bought some, but it's got some new owner. I think it's a foreign company now, but it's still a good product. And then a little bit on this brass pin. Then this needs to set a while. How long? Well, I don't know. I usually like to set it overnight. Remember, it reacts or sets in the absence of oxygen. It's an anaerobic. Get it flush there. Now, if you don't like this method, you can thread this shaft and put a thread on the crank. A lot of room for error there. Or you can pin it or set screw it. With the little pin here, you could knurl it and then drive it in. So you got all kinds of options. Now I'm going to quit for the day. My friend's wife made me a batch of Divinity fudge, and I hear it calling me. And it's got pecans in it as well. The most difficult recipe to follow is Divinity fudge. And you know, you can buy it sometimes at the store, but it's absolutely horrid, the commercially made, mass-produced stuff. It's just no good. Okay, I will see you tomorrow.